Good afternoon, fellow space professionals. My name is Timothy Fukuyama, and this is my market segment and business model for ORCA, or Orbital Rendezvous and Centrifugal Assist, for Module 2.3. I took the feedback from some of my classmates to heart regarding the feasibility of this more complicated LBCP compared to my other proposal, but ultimately settled on ORCA due to the conceptual novelty and potential to corner the market for new customers. As discussed in my previous presentation, the centerpiece for ORCA is the construction of an orbital station intended to provide increased range capacity for deep space probes. The customer must procure a separate launch vehicle to get their payload into low Earth orbit in order to rendezvous with the station. ORCA will span the gap in cost, as well as delta V, between light LEO launches and heavy launches that typically service deep space missions. Once docked, a counterweight will be placed at the correct location to offset the mass of the vehicle, balancing the station for rotation. The customer's vehicle will then induce a slow rotation into the station, expending a minimal amount of propellant. The yellow arrow represents the velocity of the vehicle per phase of the maneuver. The station will then begin gradually retracting its arms, both the vehicle and counterweight together, to maintain balance. Due to the conservation of angular momentum, the reduced radius of the station's arms increases the velocity of the vehicle as it approaches the center. The increased stresses and forces exerted on the vehicle means that this method could only ever be utilized for non-human spaceflight, and would likely mean that ORCA would need to be integrated into the customer's payload development as early as possible. The size of the station would also influence the efficiency of the vehicle's final velocity. In short, the longer the arms, the more margin there is for fuel conservation and higher velocities. At the prescribed moment, the docking apparatus is disengaged and the vehicle is flung from the station on its intended trajectory. The vehicle is then free to conduct whatever attitude adjustments are needed to meet the mission profile. The station will then begin procedures to arrest the induced rotation and extend arms to await the next customer. ORCA addresses several problems or limitations within the deep space activities. First and foremost is the barrier to entry due to the cost of current launch vehicles that are capable of entering such deep orbital regimes. Most deep space exploration is reserved for government organizations that have the capital to pay to play. Fuel expenditures typically limit the amount of maneuvering while in deep space and almost prohibitively prevent return to Earth of any physical samples. Finally, any maneuvers to change planes from the limited launch site locations available reduce the options for trajectories of probes. The station could be oriented in virtually any direction or attitude prior to the initiation of the centrifugal assist to meet the customer's mission requirements. ORCA is an in-space augmentation to existing launch services. The primary customers would be organizations looking to further deep space exploration and scientific research, government being the existing player, and due to the reduced costs of flight, academic institutions around the world. I also foresee new companies looking to contract with ORCA in order to explore resource surveying and extraction from asteroids. ORCA's business model is definitely centered on serving as the intermediary between space launch and deep space operations. The customer will need to procure their own ride to LEO and operate their own payloads throughout the mission's lifespan. ORCA will reduce the overall mission cost and provide capabilities that are not currently available with existing technologies. ORCA will have high startup costs due to the R&D required to establish the first station and demonstrate proof of concept, though operational costs should be minimal and cadence of mission support to customers should be high, further driving up revenue. ORCA will be competitive due to its breaking barrier to entry for small commercial or academic deep space payloads. The mechanics for how the ORCA stations operate allow for trajectories that are ordinarily too costly from a delta V perspective. Finally, as the system and architecture are proven, there is potential to place ORCA stations throughout the solar system, allowing for long-term support to deep space operations and the potential for material return to Earth.